So in this problem we have a stone dropped into a pond, sending out a circular ripple, and we know that the radius increases at a constant rate of 3 feet per second. So we have our circle here, and a circle has its radius. We do know that the rate of change of radius, or the radius, is increasing at a rate of 3 feet per second. So we record that dr dt is equal to 3 feet per second. And we're trying to find out how rapidly the area enclosed by the ripple is increasing at the end of 10 seconds. So we know that we want to find out what the rate of change of area is when t is equal to 10 seconds. So we have all the information listed on the paper, and we have the diagram. We're ready to find a formula that's going to relate dA dt and dr dt. And we know that that formula is area is equal to pi r squared. We differentiate both sides with respect to time, and that gives us dA dt on the left side and 2 pi r on the right side. But because the r is a variable that's not the same as t, the variable that we are differentiating with respect to, we still have to add on the dr dt at the end. And so we have dA dt is equal to 2 pi r dr dt. We're trying to solve for dA dt, and we know dr dt is 3. So we still need to find out what the radius is. We're not given the radius here, but we're told that we want to find the area, the rate at which the area is changing after 10 seconds. We assume that at time t equals 0, the instant that the rock or the stone drops into the pond, the radius of the circular ripple is 0. But from that point on, it's increasing at 3 feet per second. So at time t equals 10 seconds, the radius should be 3 times 10, or 30 feet. And we plug that in, and we get 2 pi times 30 times 3, which is 180 pi feet per second, feet squared per second.